what I wired up in this control box. I have a very simple drawing here that illustrates the basic concept of how it works. This represents the power from a standard household wall outlet. It supplies power to two things. One, the dust collector motor, and two, a transformer. So let's talk about the transformer first. All it does is convert 120 volts AC to 24 volts AC. The reason I'm using low voltage is that I have a very large switch network in reality, and I don't want to get shocked off it, and I don't want there to be any safety concerns with that network. Going to low voltage makes it much safer, and I can run much cheaper wire as well. When the relay sees 24 volts AC, it closes this switch and connects power to the dust collector motor. So I added some arrows to the wires here just to kind of show the flow of current. So you can see the transformer supplies current to the relay, and when I close this switch, it energizes the relay coil, which in turn closes the switch and allows power to flow from the wall through to the dust collector motor. It's that simple. So now let's talk about what I actually built. This is the same circuit I just showed you with a few additions. So in reality, you have to turn the power on and off. So this is the main switch. The large one I flipped up the big red handle on, that's all that is. On the front of the control box, there's an ammeter that tells me how much current my system's drawing. That's connected in line with the hot lead. The giant red LED bulb is represented right here. It's just a giant light bulb. The transformer is still the same. The contactor circuit's the same. This is the same. So I added two LEDs here on this side of the circuit. The green one, which tells me that my doorbell is supplying voltage to my contactor. I added this LED so that down the road, if I have trouble all of a sudden, I'll know if my contactor is getting 24 volts AC or not. The blue LED will only turn on when the contactor relay is getting energized. And so that tells me that the contactor is getting a signal. So this low voltage switch network really represents about 6 different switches, but logically they all do the same thing. They complete the circuit between the two sides of the transformer that enables this LED to come on and enables the contactor relay to close. So I've just represented it simply as one switch. I have a whole nother diagram about what this switch network really looks like. The last thing I've shown on here is ground. In household AC wiring, you always have to have everything grounded with a third dedicated ground wire. In low voltage applications, you don't need to ground the boxes, but in my opinion, it's a good idea to always be smart and ground everything. The dust collector control box is grounded internally, and that ground is in turn connected to the ground of the switch network.